Noble gases are helium, neon, argon, krypton, xenon, and oganesson, and they were actually the last group of elements to be discovered. So in 1785, Henry Cavendish discovered that air made up less than 1% of an unknown substance that he was experimenting with. And then in 1885, Lord Rayleigh kind of rediscovered the same thing and was able to isolate a gas from this, but he assumed that it was nitrogen. But then in 1894, Sir William Ramsay worked with him and they discovered that this gas that he'd isolated was actually argon. And so helium was detected in the sun way back in 1868, but not until 1895 was it discovered on Earth, and this was done by heating a mineral clevite, which allows you to isolate and find a lot of noble gases. And then in 1898, Sir William Ramsay discovered krypton, neon, and xenon by fractional distillation of liquid air. And then in 1900, Frederick E. Dorn discovered radon, and then in 2006, pretty recently, the Joint Institute for Nuclear Research in Russia discovered oganesson. As a group, the noble gases are all odorless, colorless, and flavorless in their natural state. Some of them can take on these qualities if they go through some processes, but in their natural state, they are all odorless, colorless, and flavorless. They're also all monotonic and have a low boiling point, as well as high ionization energy and low electronegativities. On the periodic table, the noble gases are group number 18, and they're located all the way to the right. In the image of the periodic table that you see, you can see the column that is colored the darkest shade of purple on the far right side, and those are the noble gases. They are all non-flammable, extremely stable, and extremely unreactive. And this is because they have full valence electron outer shells, so they have all the electrons that they need, which gives them an oxidation state of 0, and it's the state that all other elements are trying to reach. And basically, because they have all the electrons that they need, they don't want to lose or gain any and make any chemical bonds. And you can see this illustrated in the atomic images of xenon and argon that you see. In their outer shell, they have all the electrons that they need. And the noble gases are commonly used in lamps and light up signs because low pressure will cause them to conduct electricity and fluorescence.
Argon is a colorless, flavorless, odorless noble gas. Unlike some other gases, it remains colorless even in liquid and solid form. It is non-flammable and non-toxic. It was discovered by Henry Cavendish in 1785 and was named argon, which is derived from the Greek word argos, meaning inactive. Cavendish formed oxides of nitrogen by passing electric currents through air, then dissolved them in water to get nitric acid, but was unable to get all of the air to react. He suspected that there was then an unidentified gas component of air. Ramsay and Ryland went on to isolate this component in 1894, and the newfound element was thus named argon. The element symbol for argon used to be A. In 1957, the International Union of Pure and Applied Chemistry changed argon's symbol to AR. Since it is part of the noble gas family, argon has a complete octet of its valence electron shell. It is the third element of the group 18 of the periodic table and has an atomic number of 18. According to the periodic trends, argon has a low melting point and weak intermolecular forces, which affects its ability to form molecules. Argon also has the lowest melting point in its period. Its electron configuration is on the slide. Argon is very abundant to the atmosphere. It is also found in the photosphere. Scientists are able to measure solar argon abundance by looking at the amount found in solar flares, lunar soil, solar wind, and samples from Jupiter's atmosphere. Most of the argon on Earth comes from the radioactive decay of potassium-40 into argon-40. Over 99% of the argon on Earth consists of the isotope Ar-40. Due to its valence electron shell and weak intermolecular forces, it is very difficult for argon to form molecules. For this reason, it is usually considered one of the most inert noble gases. Because of argon's inertness, it is very useful in commercial setting. For example, it can be used in the formation of semiconductor materials. Argon is also useful in welding, as it can protect substances from the corrosive properties of oxygen and nitrogen. A fun fact about argon is that incandescent light bulbs are filled with argon to prevent the filaments from oxidizing. Helium is the second most abundant element in the universe, next to hydrogen. Helium is colorless, odorless, and tasteless, and has a very low boiling point. Helium is small and extremely light, and is the least reactive of all the elements. It does not react with any other elements or ions, so there are no helium-bearing minerals in nature. Helium was first observed by studying the sun and was named after the Greek word for the sun, helios. Helium was first discovered in 1868 by the French astronomer P.J.C. Jensen, who was studying the chromosphere of the sun during a solar eclipse. He used a spectrometer to resolve the light into its spectrum, in which each color represented a different gaseous element. He observed a new yellow light, concluding that it indicated the presence of an element not previously known. In 1895, the existence of helium on Earth was proved by Sir William Ramsay. Heating a radioactive mineral released an inert gas, which was found to be helium. This helium is a byproduct of the natural decay of radioactive elements. The chemists Norman Lockyer and Edward Frankland confirmed helium as an element and named it after Helios. 20% of industrial helium use is in welding and industrial applications. Helium protects the heated parts of metal such as aluminum and titanium from air. Mixtures of helium and oxygen are used in tanks for underwater breathing devices. Due to its low density, helium gas allows oxygen to stream easily through the lungs. Helium remains a gas even at temperatures low enough to liquefy hydrogen. Helium is one of the lightest and least dense of all chemical elements, thanks to the chemical stability and extremely small size of a single helium atom. Helium's low density is what causes balloons filled with the gas to float, buoyed by the denser surrounding air. Helium is often inhaled from balloons to produce a high, squeaky voice. Helium is naturally found in the gas state. It is the second least reactive element and noble gas, after neon. Its low atomic mass, thermoconductivity, specific heat, and sound speed are greatest after hydrogen. Due to the small size of a helium atom, the diffusion rate through solids is 3 times greater than that of air, and 65% greater than that of hydrogen. The element is inert, monatomic in standard conditions, and the least water-soluble gas. Helium is the only element that cannot be solidified by lowering the temperature at ordinary pressures. Helium has 8 known isotopes, but only 2 are stable, 3He and 4He. Because helium is easily compressed and non-toxic, it is used in specialized breathing mixtures of gases for very deep scuba diving, as a replacement for the nitrogen that makes up 75% of our air.
The symbol for neon is Ne, and its atomic number is 10. Neon was discovered by 2 British chemists, Sir William Ramsay and Morris M. Travers, by experimenting with liquefied air in 1998. For the most part, neon is used in bright advertising signs, and it can be mixed with helium to make lasers. Neon's name came from the word neos, meaning new in Greek. Neon makes up 0.0018% of the Earth's atmosphere. It is colorless, odorless, and tasteless, and is the 4th most abundant element in the universe, but pretty rare on Earth. When in liquid form, neon is freezing and can cause immediate frostbite if touched. When neon gas is electrified, it gets excited and glows a red-orange color. Neon is produced by stars. It is very inert, but sometimes forms compounds with fluorine. It contains 10 protons, 10 neutrons, and 10 electrons. Because of the electron configuration, neon is very non-reactive, but when it enters a plasma state, it glows red. Neon gas is an allotrope of neon, and it has 3 common isotopes. The symbol for xenon is Xe, and its atomic number is 54. Xenon was discovered by the same British chemists William Ramsay and Morris M. Travers in 1898, shortly after their discoveries of krypton and neon. This element, along with neon, was discovered by experimenting with liquid air and was found in residue left over after it was evaporated. Neon is often used as a light source in high-powered lamps and camera flashes, and it is often in car headlamps. Xenon also has a propulsion property that is often used to help satellites orbit in space. The word xenon comes from the Greek xenos, meaning stranger. It is the densest and the most expensive of the noble gases. It creates a blue glow when it's electrified. Xenon contains 54 protons, 77 neutrons, and 54 electrons. It has 4 common compounds and 7 common isotopes. It can only react with fluorine, and it is colorless and odorless like the rest of the noble gases.
Radon is the chemical element Rn. It was discovered in the year 1900 by Frederick Ernest Dorn, a German chemist. He discovered radon while studying radium's decay chain, where radon is often obtained from today. Its atomic number is 86, its atomic weight is 222. Its melting point is negative 71.15 degrees Celsius. Its boiling point is negative 61.65 degrees Celsius. It is a dense gas at room temperature, and its density is 9.73 grams per centimeters cubed. Radon is a radioactive element. It's often used in the monitoring of seismic activities and volcanic activities. It's also used to treat cell damage and cancer, like radiation therapy. It's used in x-rays and in industrial radiography, and it's used to track air masses in different parts of the atmosphere. Its name comes from the Latin word nitens, which means shining. This is probably because when radon is cooled below its freezing point, it emits a bright yellow-orange luminescence. Exposure to radon is equal to radiation exposure, and it's one of the heaviest and most dense gases known to us. Krypton is the chemical element Kr. It was discovered May 30th of 1898 by Sir William Ramsay and Morris M. Travers. They discovered it while studying liquefied air when small amounts of krypton remained after the other components of liquid air had boiled away. Its atomic number is 36. Its atomic weight is 83.8. Its melting point is negative 157.36 degrees Celsius, and its boiling point is negative 153.22 degrees Celsius. It is a gas at room temperature, and its density is 3.75 grams per centimeters cubed. It's often used in light bulbs for photography because it produces a bright white light. It's also used as a filling gas for energy-saving fluorescent lights. And lastly, it's used by astronomers to measure amounts of nucleosynthesis in regions of interstellar space. Some other facts about it is that its name originates from the Greek word kryptos, which means hidden. There's about 0.00014% of krypton in Earth's atmosphere, and it's produced in Earth's crust from the decay of thorium and uranium. Krypton gas emits bright white light when it is ionized.
Oganesson symbol is Og, its atomic number is 118, and its atomic weight is 294 units. In 1999, the Lawrence Berkeley National Laboratory claimed to have discovered it by bombarding lead-208 with krypton-86 atoms. But in 2002, their discovery was redacted because some of the data had been falsified. Then, in 2006, the Joint Institute for Nuclear Research in Russia claimed that they had produced oganesson by the nuclear reaction of calcium-48 at an energy of 245 million electron volts with californium-249, and that they had made 3 neutrons and 1 atom of oganesson. And oganesson is named after Yuri Oganesson, who was the lead scientist for the Joint Institute for Nuclear Research in Russia for the team that produced oganesson. In 2016, oganesson was recognized as an element by both the International Union of Pure and Applied Chemistry and the International Union of Pure and Applied Physics. So oganesson, not a lot is known about it because a millisecond after it's created, its nucleus will decay and become livermorium by emitting an alpha particle. And so we don't really know any physical or chemical properties because only a few atoms can be produced. But we do expect that its chemistry reflects metalloid properties, and so we also know its electron configuration, which is listed on the slide.